Hi, everyone. My name is Ina Paricio. I'm a marketing manager here at EDB. I will be your host today for our webinar, Security and Containers in Cloud Native PostgreSQL. I'm joined by Adam Wright, Senior Product Manager at EDB. Before I turn it over, I'm just going to go through a few housekeeping items. Number one, this presentation is being recorded, so we will be sharing the recording at the end of the presentation. Second, the lines are currently muted, so if you have any questions, just drop it in the question panel. So if we have time at the end of the webinar, we just go over all the questions, and if we don't have time to answer all of them, we'll just make sure to follow up with you afterwards. With that said, I will hand it over to Adam to kick us off.
Hello, everyone. As Ina mentioned, my name is Adam Wright. I am a product manager at EDB, responsible for containers and Kubernetes. This is a combination that makes up our product offering, Cloud Native Postgres. I'm also product manager for our backup solutions, Barman, and then contributions EDB makes to the PG Backrest community. Today, we are going to talk about the security aspects of Kubernetes and the containers themselves, and how Cloud Native Postgres leverages those features, or in some cases, simply benefits from them. All right, so on today's agenda, we're going to talk briefly about EDB Postgres and Kubernetes relative to Enterprise DB, a reminder about exactly what Cloud Native Postgres is. And in the Kubernetes community, there's a security model known as the 4 Cs, representing 4 security layers. We'll talk about the Cloud Native security model and discuss 3 of those 4 layers in more details. The ones that we'll discuss are the cluster layer, the container layer, and the code layer, or the code layer, sorry. Each layer is critical, as security holes in the base layer of a container can be used to exploit the cluster layer, which then needs its own protection to safeguard against such holes, and thus building defense in depth, a concept many of you will be familiar with. Throughout the presentation, you should notice how, like Kubernetes, Cloud Native Postgres was designed with an eye towards security. Many best practices in Postgres, that require heavy expertise and heavy configuration. We're sensitive to that, and we've been able to code in those defaults, by focusing our container strategy on container orchestration with Kubernetes. And for now, we're going to do a quick poll to see where many of you are at, running databases on Kubernetes and security as well.
All right, so we'll go with question number 1. So, are you running any stateful applications using Kubernetes in production? And then the answer is yes or no. I'm going to leave it up for 15 more seconds. It's pretty tight right now, the results. And all right. So results, so 55% of the participants said no, and 45% say yes.
Okay, that's the yes is actually a little bit higher than I would have thought. So yeah, that's great.
Cool, and then we'll go with poll number 2. Do you find securing applications to be more or less challenging in Kubernetes? The 2 options are more or less. Okay, and I'm going to keep this running for 15 more seconds, so make sure to get your answers in. All right. All right, so 76% of the participants said more challenging.
Yep. Yeah. Thank you for that, and thanks everyone for responding. Yeah, I think the challenging, 76%. Yeah, that's probably what I would have expected. I think what you'll see in this in this presentation is that you have a lot more tools available to you for securing your application. And some of those by default are going to be more secure in Kubernetes, but there's a lot of new, there's a lot of new out there for how you configure those. And there are a lot of vendors popping up with different mature solutions. So yeah, I think we'll be able to address those. That's good information for us to have. Thank you. All right, so going the wrong way here. So objective, so a lot of vendor talks that give product overviews and demos will often, have the question at the end, what about security? And if you find security to be harder to implement, or you're close to the 50% who aren't yet running stateful applications, that's probably a fair question to ask. What about security? It's a very generic question, but we talk to a lot of customers with database backgrounds, and you're very familiar with how to secure a virtual machine or a database server software that's running, just on Linux itself. So what about X, Y, and Z that we're using? How does the DBA's life look different? How does the system administrator's life look different? Because the transition to Kubernetes, it brings a whole new set of security features and access controls. In some cases, you'll want to implement security features that are native to Kubernetes, and maybe some features or some controls that you wanted to implement, with virtual machines or bare metal workloads, you're able to better implement through Kubernetes. I'll give one real world example here. I talk to a lot of DBAs and system administrators who struggle with implementing change management workflows, especially around configuration files like the PGHBA, the host-based access control, that have serious security implications. And with Cloud Native Postgres, configuration is implemented declaratively. So it's very straightforward to enforce a configuration file or configuration that's defined in the file by having it in your code repository, by only applying the configuration from your main branch. Any rogue changes via the command line, they'll just be rolled back with your continuous job that applies that configuration from your main branch. This is a small detail, in the bigger security view, but it highlights new ways to look at access controls, new ways to look at configuration management, and be aware of some of the security features that are inherent to Kubernetes. So the main objective of this talk is to highlight the layers of security features available to you when you're running PostgreSQL in Kubernetes. All right, so EDB Postgres and Cloud Native, let's give a quick overview. EDB is the largest dedicated Postgres company in the world. We're a global company, over 5,300 lifetime customers. The big number right there in the middle, over 300 dedicated Postgres technologists. This comes all the way up from developers, contributors to the Postgres project, to consultants, solution architects, customer success. People that are full-time jobs are working with Postgres. High customer satisfaction ratings. 28% of the Fortune 500 companies are customers of EDB. We have many customers deploying on the cloud, 40% deploying on the cloud. As applications tend to go places first, whether that be virtual machines, cloud workloads, Kubernetes next, and then the cloud, and then the database coming next. And then two of the founders of the Postgres community are at EDB. And so the reason this is important is because we're talking about Kubernetes, but what gets deployed is actually Postgres. So having your Kubernetes vendor be an application expert is extremely important. So the EDB team includes, contributors to the Postgres community, committers to the Postgres community, and these are contributors, working on big and small things. So, things like table partitioning, logical replication. We have community members that have worked on those projects. So big features, big extensions like PG Logical, big, even proprietary tools like BDR that rely heavily on the advanced features of Postgres. So I think we've established, EDB is experts in Postgres, largest dedicated Postgres company. Now that we have our second generation container offering, we want to be Kubernetes experts as well. And I think we've achieved that. So EDB is a member of both the Linux Foundation and the Cloud Native Computing Foundation. We are a Kubernetes certified service provider, the first and only that I know of Postgres company to reach this level. We build our container images on Red Hat UBI and publish them to key.io, and that in our software is certified on Red Hat OpenShift. We have two products, Cloud Native Postgres, and then later this year we're launching Cloud Native BDR. The important point here is that you're getting Postgres from Postgres experts, and we are also Kubernetes experts as well. So what makes the EDB solution unique? Well, we have unique products. We have Postgres Advanced. We have the bidirectional operator coming later this year. No external dependencies. We've built the HA management tools into the operator. We didn't have to go to this GitHub project, that GitHub project, and sort of just melt those together to come up with a solution. So Postgres experts and Kubernetes experts. All right, so now that we're done with that overview, talk about CNP real quick, just to make sure that you have the full context for the discussion today. So Cloud Native Postgres and BDR, these are operators. It's important for this conversation that you understand what operators are. So operators, we've written the Cloud Native Postgres operator in Golang. It's fully integrated with a Kubernetes API server. It's designed for Kubernetes, no external tools. So all of the operational aspects of running a Postgres database are built into the operator. We build immutable application containers for Postgres 10 and higher, and EDB Postgres 10 and higher, and this has serious security benefits that we'll show later on. And again, we're planning to release the BD operator later this year, which is the Kubernetes operator, but the replication technology being used is different. All right, so the Kubernetes operator, this is essential to know, right? It's an extension of the Kubernetes controller, defines how complex applications work. So if you're deploying a web server, your web server goes down, it's not responding, then Kubernetes can just restart that web server. If a node goes down, just restart the web server on a different node. But Postgres is a complex application. So we've taken the Postgres expertise and extended Kubernetes to understand Postgres, right? So if a primary goes down in the Postgres world, then we're going to perform a switchover. But we're leveraging Kubernetes features like reconcile loops to monitor that behavior. If standby goes down, then we can try to revive that standby or add another standby. So the operator relies on Kubernetes for capabilities like self-healing, high availability updates, access controls, and so on. And then the Postgres expertise is built into that. And it's designed to be fully automated and support declarative configuration, which we'll show later on also has security implications. So when I say, Cloud Native Postgres, what is it actually? Well, it's PostgreSQL and EDB Postgres Advanced images. These are Docker container images containing only the database server software and the Kubernetes operator for deploying the database server software that runs. So the operator and the operands. We've also extended that, assign a maturity for our operator. We have a kubectl plugin. So, if you're running Kubernetes today, you're starting to learn Kubernetes, you're going to interact with the kubectl, CLI quite frequently. And, instead of having another tool to interact with the Postgres cluster, we have a plugin that allows you to view things from the perspective of someone managing a DBA. So this is a plugin for the tool that you're already going to be using. It's not a separate tool. And then we also have a benchmarking tool, CNP Bench, to ensure that the database is production ready. So there's lots of storage plugins out there. There are lots of storage options, much more than you would probably have, your virtual machines and VMs. And we help with this project to help you benchmark the environment, make sure that it's production ready. So both are available on GitHub and CNP Bench is an open source project. Capabilities deploy anywhere. So you have the same operational task, whether it be on premise, in your private cloud, or whether it be in a public cloud provider, or a Kubernetes distribution in the cloud. Kubectl, apply, install the operator, install the operands. Automate DBA tasks, failover, switchovers, backups, recovery, rolling updates. You don't need separate standard operator procedures, and avoiding lock-in. So operator images are portable to any cloud, and the backups are standard Postgres backups that are stored in your storage location, so you can take those anywhere. So imperative versus declarative. So when we talk about configuration management here in a little bit, what we're talking about is the operator ensuring that the deployment is how you declared it in your custom resource. So again, we're using Kubernetes native features. Desired state is the desired state of an object is going to be enforced, and we're using the EDB knowledge to enforce that. So desired state, hey, I want to deploy a cluster with I want three pods in my deployment. So it's instances : 3, and then Kubernetes is going to say, okay, we've declared 3, so the actual state, give me a primary and give me 2 standbys. Now I have instances 3, primary, 2 standbys. We set up stream of replication. One of the pods goes down, then the operator is going to bring back another standby. We have the expertise to be able to say, hey, this is what happens when it's a standby that goes down. The primary goes down, then we're going to perform a switchover, and then we're going to bring the standby back to the cluster. And then if we want to scale up, we just change our configurations, instances : 4, and the operator takes care of that. And then the actual state is going to be 4. And then you can also go the reverse way and scale down if you need to. So it's important to understand how we're integrating with Kubernetes and how we're doing everything declaratively, because if you take a look at the security overview that's actually provided by the Kubernetes community, you'll see the idea to start thinking about security in layers, sort of a defense in depth approach. For Cloud Native Postgres, or for Cloud Native in general, this is known as the 4 Cs: cloud, cluster, containers, and code. And you'll find each layer, shielded by a surrounding layer with its own set of security defenses. The outermost layer is the cloud layer. With Kubernetes, this could be a cluster you run in your own data center or co-location space or in the public cloud. Many vendor distributions like Red Hat, OpenShift, SUSE Rancher, provide their own recommendations for securing the cluster. And take away the administrative complexity. Kubernetes clusters, managed services for Kubernetes clusters are extremely popular, and they come with their own set of recommendations. The cloud layer is beyond the scope of this webinar, and we're going to focus on the cluster layer, the container layer, and the code layer here. All right, so let's start with the outermost layer, in our case, the cluster layer. So again, the cluster management approach that EDB took with Cloud Native Postgres is unique among Kubernetes operators for managing databases. So the cluster management is handled by the operator. There are no agents inside the database containers. So all communication has been implemented with best practices around security. The Postgres cluster has its own service account that communicates with the Kubernetes API server as an unprivileged user. This unprivileged user reports the status of the cluster back to the control plane. The communication only happens over HTTPS with TLS certificates for authenticating. All communications encrypted. For the cluster layer, we've implemented best practices around role-based access control with minimal privileges and enforcing secure communications. The decision to design for Kubernetes, also impacts the container layer, by allowing the containers to only have a single job to do, which is running Postgres. So we've benefited. The container layer benefits from the design decisions here at the cluster layer itself. This is stuff that happens automatically that you don't have to be aware of. What we've gotten from customers and financial institutions, defense agencies, they ask us to provide this information for how it works. But this is all handled automatically for you. Node affinity support, so affinity, anti-affinity rules, node selectors, they all have a broad set of use cases. For databases, you might be deploying a large database and you want to pin that database to a Kubernetes worker node dedicated to running a database workload with many CPUs, lots of memory. So you get the operational benefits of Kubernetes, but you also have high performance requirements. You need local storage. That might be a consideration, keeping the primary and standbys on separate hosts, separate availability zones. But there are security use cases as well. So you can define node selector rules. If you're storing sensitive data, you could pin a database to particular worker nodes. These would be worker nodes that are allowed to run, HIPAA workloads, PCI workloads. So they have, either lockdown more strictly or have different access control, different monitoring controls. Postgres does not require an extensive list of syscalls on the host. So monitoring syscalls at the host level, it would be pretty easy to see what activities are not initiated by the operator or not initiated by Postgres just by filtering out the allowed syscall list. So this comes up during regulatory workloads as well. So you just have a label on the Kubernetes host, use label selectors to make sure that the pods get scheduled on the appropriate host. So this is quite powerful in practice, getting all the operational benefits for cluster management, but you don't have all of the, you don't have to manage multiple clusters if you don't want to. Just one more on the documentation. I'll point to the link later on, but there's a section on scheduling that covers this in detail. Explicit security context. So a security context defines privileges and access controls for a pod or container. Cloud Native Postgres now explicitly sets the security context for the pod to be run as non-root, to not allow privilege escalation, and to mount the container's root file system as read-only. So supporting security context, pod security policies, it's important to understand that, thanks to immutable application containers, we don't need root privileges to run our containers or to access volume. So this is a good example, again, of the different layers building on one another. System components designed for the environment, really being cloud native to benefit from one another. So the end result, again, no privilege mode required for the containers, no privilege mode needed for volume access in the host. It's set explicitly by the operator. And that third bullet, related to immutable application containers, with support for read-only file system. We're not just rolling back changes if a new operator image is available. No configuration changes, scripts, no additions or new software can be added to the system. The root file system, it's mounted as read-only. The PG data volume is attached to the pod. So all changes need to be declared in your custom resource. And so this is, again, best maintained in a code repository with the appropriate checks and approvals. So, if you do have security reports that you need to provide, that custom, everything being defined in your custom resource, it's very nice to be self-documented in those regulatory requirements. For our joint Red Hat OpenShift customers, your CNP deployment will now run under restricted SCC by default. There's no caveats there. We're not talking about a special restricted SCC, with added capabilities. It's the full out-of-the-box restricted SCC that comes from Red Hat. As you can see from the call-out box, and as stated in the OpenShift documentation, restricted SCC is the most secure security context constraint. Restricted denies access to all host features and requires pods to be run with a UID and SE Linux context that are allocated to the namespace. This really opens up running Postgres and Kubernetes in an environment that requires strict rules applied to Kubernetes workloads. Things that were previously, being restricted to application workloads, and this really opens up for running database workloads in those environments as well. Feedback that we've gotten from customers in other contexts is, they want encrypted communication by default. Setup can be cumbersome for those who are new in the Postgres world. You have a lot of new things to learn. In many cases, we've heard from new customers who just assumed, Postgres communication was encrypted by default. Not to mention, wanting to take that a step further with TLS certificate authentication. With Cloud Native Postgres, the operator automatically creates a certificate authority for itself to ensure safe communication between the Kubernetes API server and the operator. But the operator automatically creates a certificate authority for every Postgres cluster, which allows TCP/IP connections to use SSL communication, which is the default for most Postgres drivers. And then you can take that further and explicitly set it in your communication string. By default, the application typically tries an encrypted connection and falls back to unencrypted if not available. But in the case of CNP, there's no need to have that fallback mechanism. You can enforce that with confidence in the application. So SSL on is the mandatory Postgres setting, and it's managed by Cloud Native Postgres. And to avoid any downtime in the future, the operator will auto-renew certificates close to its expiration date. Other feedback we've gotten from EDB customers, alluded to this earlier, is that they really want to use certificate authentication, but the setup can be, extremely cumbersome. We've attempted to simplify this. Instead of your application having to manage many passwords and secrets, if you're doing deployments at scale, especially go into microservices, a TLS certificate can be generated from the kubectl CNP plugin that I mentioned earlier, and then used as the mechanism for performing authentication. All right, so hopefully you can start to see, the design pattern with Cloud Native Postgres. Features are implemented again with an eye towards security out of the box, for both Postgres and Kubernetes, and using the principle of least privilege. So this shows, with the details of streaming replication, I think this really highlights that point. Instead of having another password to manage, CNP programmatically sets up a certificate authentication, a certificate authority, no password stored anywhere, and then uses certificate authentication for the streaming replication, the user that performs streaming replication. So the streaming replication user only has the privileges it needs for wall sender and wall receiver communication. The super user password is never used here. The streaming replication user only has replication privileges, can only connect to the replication database, which is just a keyword, not an actual database, and authenticates with a TLS certificate with SSL mode set to verify CA. All right, so I mentioned this a few times that the operator generates a certificate authority and uses it for client-server authentication, and they are managed and renewed automatically by the operator. CNP provides the option of bringing user-provided certificates, so bring your own certificates, allowing for integration with things like Cert Manager, Kubernetes certificate management controller that helps issuing certificates from a variety of sources. And for streaming replication, the configuration is set to the SSL mode level with verify CA. So you can use those same SSL mode settings. You can bump them up with your application to something like verify full to protect against man-in-the-middle attack with client to server communication. And if you're working in Kubernetes, you're probably familiar with the way secrets work. If not, it's fairly well documented in the Kubernetes community. But this is how you our bring your own cert works. Allow you to store the certificate in the namespace of a CR. A strong feature for supporting multi-tenancy Kubernetes deployments. Right, so when initializing a new cluster, the operator can create a new database and create a new owner of the database. The database configuration is the new database that gets created during the deployment, and then the owner is the owner of that database. Fairly straightforward, but this is all done by the operator when you're initializing a new database. So the bootstrap method in this example is initdb. So we're going to initialize the new database with those initdb options there. We're going to create a new database, create a new owner of the database, and then we are also going to set the password for that owner with the secret name, with the configuration that's in, or the values that are in that secret name. What's really nice about this is you have a consistent process that can be used from local development to production deployments. This really makes it easier to have your separate applications on their own CNP deployments. So if you're building microservices, or you're converting a monolithic application to microservices, CNP makes it a lot easier to have one application per one Postgres cluster. But that all depends on your isolation level. One application per Postgres cluster, you can have multiple applications, each with their own database in a single deployment. Or you can have the least level of isolation, the smallest level of isolation, one application per schema on a single database. These are typical Postgres use cases that apply here, but we just make it a lot easier for you to do the deployments per application. So this gives separation if one in isolation, if one application does expose the database, and it also makes password management a lot easier. Something that's going to be increasingly more difficult as you get into the microservices world. And instead of having a few big databases, you have many databases. With an eye towards the future, with Cloud Native Postgres, we are looking at extending global object management in the cluster resource definition, allowing you to perform many of your typical DBA tasks, declaratively through the operator. In fact, there's a new configuration. We make it possible for you to deploy a CMP cluster with no super user password set anywhere. So this would require a bad actor to have to exec into a cluster, which you can then disable at the Kubernetes cluster level. A best practice already for production deployments. Right, and for customers who need to pass government or financial audits, you often need to produce audit logs. This is also the case in the federal government with the Security Technical Implementation Guide, the STIG. For Postgres, PG Audit can be used to generate audit logs. And for advanced server, we have a tool called EDB Audit. PG Audit and EDB Audit are both available with CMP out of the box. What you'll find with Cloud Native Postgres is that it's really easy for these logs to be consumed by external logging systems, your SIM. You can easily send, the logs that are relevant for DBAs to one logging system, and then filter out only audit events and send those to a SIM or another logging infrastructure that's used by the security team. And we'll see why that's the case here in a second. So integration of PG Audit into CNP. This is an extension that has to be installed in the Postgres container image. So we include PG Audit automatically. It extends, the logging collector that's already there with CNP. And I mentioned, how you can do that filtering. Well, there's a logger that's set to PG Audit. So you could have your logging system only take events that are PG Audit, or if they're going to DBAs who don't need that information, or it's a duplicate from other settings, you could filter out those PG Audit events. So we parse the CSV format for PG Audit and send that to standard out as record.audit in JSON format. You'll see that here in a second. So if you enable PG Audit, then we're going to create the extension on the template one database. So any databases that you create on that deployment are automatically going to have the PG Audit extension. And so if we go to this screenshot here, what you might notice is in this deployment YAML, my custom resource, we don't have anything for shared preload libraries. And that's because the operator automatically detects that, hey, there are PG Audit configuration settings, and automatically adds the extension to the shared preload libraries. Like I mentioned on a previous slide, then we add PG Audit to the template one database, and then PG Audit is going to be available on any new databases that are created. So your audit settings are again controlled. It's very easy to do configuration management here. Your cluster resource definition at the global level will allow you to set the PG Audit settings. And then you can ensure that those are always applied by just having a job that applies that custom resource. So this allows you to enforce, hey, no changes are made unless they go through our code repository, which has the necessary checks and balances. On this screenshot here, you can see all the information that PG Audit provides. What we've done is just parse the CVS and put it as JSON output, the standard format for most logging systems these days. So in this case, you can see the command that was issued, select system identifier from PG control system function, who the database, the username, and the log time as well. And then you can see toward the top there is the PG Audit logger. Integration of EDB Audit and CNP. So the logger for EDB Audit is going to be EDB Audit. So everything I mentioned before about PG Audit, if you're using an advanced server, applies here. You can filter, send these to different logging systems. All that you have to do to enable EDB Audit in CNP is just set the configuration to audit true. And then you can see here what all of the default configurations are going to be when you set audit to true. So this just makes it a lot easier for you to implement an auditing solution, makes it a lot easier to get these audit logs out into other systems, sort of leveraging the Kubernetes infrastructure and taking these Postgres tools that handle the job, but integrating them better with the infrastructure. All right, so EDB, these are what the EDB audit JSON logs look like. So you can see again, the PostgreSQL configuration, it's an EPAS specific configuration, and audit is set to true. And then when an audit event is going to look like this JSON record here. And then you could see the EDB audit logger definition, and then again, some of the same information, username, database, and then this was a grant command that was issued. So some permission changes were made to an object, and that got logged by EDB Audit. Default PG HBA settings. So again, we're talking about, doing security in layers for Postgres, the host-based access. This can be customized declaratively. This is the default configuration, but if you know the IPs within your Kubernetes cluster, you could say, hey, only this IP can connect. You can change the storage type for the password, MD5. You can use other methods as well. And you could also use TLS certificate authentication if you wanted to. But again, the big thing here is that you can do this declaratively. It's not someone logging into the database server, going to the PG data directory, manually updating the PG HBA file. This is done declaratively, can be controlled through your code repository. And then it's also building on other features. So if you have network policies that you can, Kubernetes network policies that you can apply to the namespace where you're doing a deployment, then you have different layers of security that complement each other, or if there's a hole in one layer, allowing it to be blocked at the next layer. This just makes it really easy to do. All right, so let's go into the next layer and talk about the containers themselves. With the second generation container technology from EDB, we decided to standardize and focus on Kubernetes. So this really allowed us to get to the mutable application design here, paradigm. So this is built for microservices. This means that all the operational logic is being handled by the operator, so we don't have to put a bunch of agents into the database. So we're kind of blazing a new path for databases. This is really popular with application containers, but fairly rare with databases. So you can just think of the container as being a single application, that application being Postgres, the Postgres process, the postmaster process itself being PID1. In fact, the EDB Postgres Advanced images themselves do not even contain an entry point. So this makes the images very lightweight. Support 2 different base image types. We allow you to deploy with UBI minimal or Debian minimal, so you have a choice there. So if you have like container scanners that are, more geared towards UBI, Red Hat distributions, or geared towards Debian, then that might dictate your choices there. And because we don't have many software dependencies, the container images, being lightweight has many benefits, but one of them is just having a minimal attack surface. So only the Postgres software running, by a non-root user Postgres, no SSH, no systemd, no syslog in those containers. If there's a security update to the base image or a new minor update of Postgres, then we're going to update, then the entire image is going to be swapped out. So the operator itself will perform the rolling updates, starting with standbys, rolling up, finally performing a switch over from the primary to and promoting that standby server, and then bringing up another replica. So all of the container images would just be swapped out with a new image that contains, the latest security updates and the latest updated PostgreSQL. From an operational perspective, this makes patching much easier. You don't have to go build a bunch of scripts or different standard operating procedures. You're just, applying the latest image to the cluster in your custom resource. Tag immutability through digest, it's important to ensure that the same image that's deployed to the Kubernetes cluster is the same image that was verified by the software vendor. So in our CICD pipeline, we go through many different checks, and it's important that the image that we've built is the image that finally gets deployed in your production environment. So if the image is hosted on key.io or Docker Hub, they come with their own security check tools, but we also have a SHA-256 tag. So that's how the image is identified. And this helps you to ensure that you're actually deploying the image from EDB, and no extra software has been snuck into the containers. So with a nice way this has been implemented is you have a human readable tag, so DevSecOps teams, they can quickly identify a version of the software. They can quickly identify the base image of the software, the database version number. So that's easily human readable, but then we also have the SHA-256 hash to ensure that it is the actual image that you intended to deploy. So the way the image is, just to decipher this, so image name, key.io, that's the container registry. We're pointing to a public container registry. The enterprise DB is the repository, and then PostgreSQL. So this is the community image version 13.4. If there is an update to the UBI image, then we would put a dash on that and be -1, and then -2, -3. And then if a new minor updated Postgres comes out, 13.5, then this is going to be PostgreSQL :13.5. And when a UBI update comes, to be 5-1. All right, now let's finally look at the code layer here. So in this animated slide, I try to highlight some of the best practices that we're implementing with DevOps at EDB, especially around Cloud Native Postgres. So it all starts with developer writing a patch or a new feature for Cloud Native Postgres. The patch is then pushed into a version control system, like Git. And then a pull request is issued. And that's the general workflow in the beginning. And what we have is sort of a shift left philosophy here, where we have multiple reviewers for a patch. We also have several automated test and static code analysis through linters. And then we run a series of end-to-end tests in Kubernetes. So from a stability standpoint, we'd have a matrix. These are the versions of the database support. These are the Kubernetes platforms that we support. Let's run end-to-end tests on each of the database platforms with each of the database versions, or each of the Kubernetes platforms with each of the database versions that we support. So I think it's important as we talk about security, talking about DevOps, talking about deploying applications of code, that we're actually implementing many of these same practices within EDB. Right, so as we go on, so it's one developer does a patch, multiple reviews, push to a version control system, automated testing, code static analysis, container images, all of the end-to-end tests must patch, and then that gets merged onto the main branch, pushed to a container repository. So this would be Docker Hub, this would be key.io, where you could pick up those images and available to the end user. These repositories, Docker Hub, have their own container scanning tools. Key.io has its own container scanning tools. If there is a vulnerability, a CVE in those images, then you would see a report on those, even on those web interfaces. And then you have the SHA-256 hash that you could compare as you consume that as an end user to the image that EDB pushed to that container repository. All right, so there's a lot of information there. Next steps. A lot of you aren't already using stateful applications in Kubernetes and not deploying databases yet. Still looking at it. Still, learning how to secure databases or secure applications in Kubernetes. The EDB docs is a great resource for you. Everything that I talked about plus much more is going to be in the EDB docs. If you want to try out Cloud Native Postgres, there's even a interactive demo on the website. But all of the features that I talked about today are covered in great detail in the EDB docs. If you want to get started, there's trial guidance. Quick start is really easy. You can, run it on your local machine with something like Kind. You can deploy it to most Kubernetes distributions. We have the list of supported distributions on our website, but it's really easy to get started, especially with that interactive demo on the EDB docs website. So that would be my next step. I would go to the website if you're interested. Again, lots of great information there. And then, contact EDB if you need any assistance there. One plugin I don't have the slide for, EDB is hiring, so you can go to the webpage and see what positions are open. If you're interested in, being a project manager, if you're interested in, developing, operators, doing, Go development, backup development, any of those, check the open positions on the Enterprise DB website. All right, thank you, everyone. We'll see if there's any Q&A now.
All right, thank you, Adam. That was a great presentation. Okay, so a reminder here to drop your questions in the Q&A tab if you have any. At the moment, there is one, Adam. So the question is, have you tested this on VMware Tanzu? If not, will you plan on testing certifying it on Tanzu?
We have started some testing with VMware Tanzu. We've had a couple of customers who are planning to use VMware Tanzu, and some of our staff has helped those customers with VMware Tanzu. The current plan is to eventually support VMware Tanzu. It's not officially supported today, but it is in the plans. I don't have an exact date for that yet, but it is in the works. If it's a hurdle for your adoption of Cloud Native Postgres, just contact us. We can get you more details on that.
Cool, great. Another question here is, can you stretch CMP clusters across Kubernetes clusters / data centers?
Yeah, so the way it works with multi-Kubernetes communication between the clusters, we have a feature in our newer releases called replica clusters. So what this allows you to do is you have two separate deployments of Cloud Native Postgres. So you have one, say, in one region, another deployment in another region, which are in separate Kubernetes clusters. And you have an inferred replica on the remote side. So that replica is actually getting its changes from the primary in the other region. So you have the option, you could just get the changes directly from that primary, just using standard streaming replication technology that this is handled in the custom resource and handled by the operator. Or you could pull down the WAL files from an object store. So you're just basically in continuous recovery mode. So that's a feature called replica clusters. It is covered in the documentation, but that's how you do it. 2 different Postgres clusters, 2 different Kubernetes clusters. One is receiving changes from the others, and then you could promote if needed. This is a big one, especially in disaster recovery scenarios, and you could query the replica if you needed to.
Great, thank you.
Hopefully that answered you, Bryce.
Cool. All right, so I'm not seeing anything popping up.
Okay, there was one
more.
The download question. Yep. So how
Yep.
do you download Cloud Native Postgres? I'll answer that, but the documentation, if you go to the EDB Docs website, there's a quick start guide. It's basically a 2-step process. You deploy the operator. You could download the container image for the operator. It's a container image deployment. You kubectl apply, and then we have a YAML file that defines the container image. You could just do that off of a web URL. It's in the quick start guide. If you're in more of a restricted environment, you can pull those images down into your private container registry. But it's really just 2 commands: kubectl apply, deploy the operator, kubectl apply, and then you have a cluster deployment. Cluster is the type of a Postgres cluster. So it's really 2 steps there. The operator, the operands, it's in the quick start guide, really easy to get up and running quickly. Follow up from Bryce, are you able to promote a replica in another region to be primary, either automatically or via the kubectl plugin operator commands? Yes, so the plan is to be able to promote that replica either declaratively or through the plugin. The reason that we have been hesitant to support doing it automatically, and I think this applies to even traditional contexts like VMs, when you're going across region, is there's a lot of cases where you're going to have just some network disruption. So if you're relying on things like heartbeats, and you don't have, say, distributed consistency, which can be really tough, come with its own lag, and then you get split brain scenarios. That can become a lot more likely when you're talking about, sort of WAN communication and automatically promoting databases. So our guidance has really been to, if you're having to go to another region, typically that's a big event and multiple people are being brought in, and then an actual human would need to intervene at that time. So like a DevOps person would need to do the promotion manually, or have some automatic way. That's really been our reservation for, even with our traditional tools like EDB Failover and Rep Manager, for having automatic promotion over a WAN. Or 2 different Postgres clusters.
All right. I don't see anything else in the Q&A panel. So I think that with that, we are good to call it a day. So thank you all for joining the webinar. We will be sharing the recording after the webinar as soon as possible. So thanks again. Thanks, Adam, and have a wonderful day.
All right. Thank you, everyone. Bye.